A cube is given. The sides of the cube coincides with three faces of the cube, coincides with the xy, xz, yz plane, or the origin. Origin of the coordinate system is at one corner of the cube. Now, we given the electric field that is only along positive x direction. Electric field only acts on positive x direction. No other field in any other direction. The value changes with x as 5 p times x plus 2e. Everything is in SI unit. A is given as 10, B is given as 5. We are supposed to find electric flux through the cube. Then net charge enclosed within the cube. The side is 10 cm. This left face is marked as M and the right face is marked as N. When you find the total flux, there are 6 faces for the cube. Find flux through each face and add up to get the total flux through the cube. If the total charge inside was given, you could have used Gauss theorem, because that's not given, it's asked here. The other option is to find electric flux, use EA cos theta. So you need E value, A value, and theta between the directions of E and A. So if you take the top face, the electric field is already towards right. The top face, the area vector is outward. Area vector is always perpendicular and out of the surface. The top face, area vector and electric field are 90 degrees. That means the angle becomes 90, cos 90 will be 0. So the electric flux will be 0 for that particular face. Now if we check the face below, straight below the top one, in that case the electric field is again to the right only everywhere. The area vector will be straight down. So that case also the angle will be 90 degrees. Now if you take the front face of the cube, the electric field, nothing to say, towards right everywhere. The area vector will be along the z-axis, it's out of the screen. So z-axis and electric field along the x-axis, that is 90 degrees. Now if you take the face just behind the front face, the electric field is to the right and area vector is outward here. On that face, electric field is to the right still, and the area vector will be outwards from that negative z-axis. That also make 90 degree. That means all the 4 faces, the top, bottom, front and back, make 90 degree with area vector make 90 degree with the electric field. So you don't want to find the flux, it becomes naturally 0. Now the front face, the area vector to the right, because normal to the surface is to the right. In that case the theta becomes 0 degree. And the back surface M, if you look from here, the area vector is to the left. That time area vector left, electric field is to the right, then angle becomes 180 degree. So you only want to find the electric flux through surfaces M and N. The other 4 fluxes become 0 because theta becomes 90 degree in that case. So the electric flux demand EA cos theta. So we are trying to find E value first. E value is given as 5bx plus 2a. B is 5, so 5 into 5, 25. So 25x plus 2 into 10, 20. So that's the expression for electric flux with respect to x. Now for the surface M, it's at the origin. So at the origin the x coordinate is 0. So 25 0 plus 20, which is 20. Now for the right face, it's at a distance 10 centimeter from the origin. The x coordinate is 10 centimeter. Centimeter don't work for us as a unit. 10 by 100 meter, 0.1 meter. So 25 into 0.1 plus 20 will be the electric field for the right face. So 25 into 0.1, 2.5 plus 20, 22.5. Now we can go for the flux calculation. The total flux will be flux through M plus flux through N. We are counting the other 4 phases, but since each one is 0, 4 times 0, it has 90 degree. Then flux formula is EA cos theta. So this will be EM, AM cos M is 180, cos 180. This will be EN, AN and cos 0. Now cos 180 is minus 1 and cos 0 is plus 1. This is plus 1, not minus. Fine. Now this become minus because cos 180 is minus, and this is already plus. There's a mistake here, plus. So it will be minus EM plus EN. We can take EN first and EM next. It will be EN minus EM. The area of the faces for a cube is common, so whether M or N, we can write it as A. So areas comes common out. And you can substitute the value of EN and EM. So 22.5 and 20. The area of each face, the side of the cube is 10 centimeter. So 10 centimeter is 10 into 10 to minus 2, which is 10 to minus 1 per meter. Area will be 10 to minus 2 area, side square. So 10 to minus 2 into 22.5 minus 20 will be 2.5 into 10 to minus 2. So this is the total flux through the cube. Now the second part is the charge. For charge, since we know the flux, we can use the Gauss theorem. So flux equal to total charge engrossed by epsilon 0. So Q will be epsilon 0 will go left. So flux is 2.5 into 10 to minus 2. Epsilon 0 is 8.85 into 10 to minus 12. So minus 14. 2.5 into 8.85 becomes 22.125 into 10 to minus 14. If you take 10 to minus 1 from here, so 22 into 10 to minus 1 will be 2.2 and 10 to minus 13. So 2.2 into 10 to minus 13 coulomb. That's the total charge enclosed within the cube. So that's the flux volt per meter, then this is the charge. So there was a correction in the beginning. So this is plus. Then because this is already plus, by mistake it came as minus. Then the cos 180 make this minus. When you transfer minus to the right and minus term to the right and positive term to the left, you get En minus E.